Alright, grade 8. Last Sunday we have started with our new chapter, speaking about our planet Earth and the solar system. We spoke first about our star, the Sun, and we have said that the Sun is considered to be a medium star compared to the other stars in our universe. Yet the Sun is magnificent compared to our planets in the solar system. It approximately has the uh, mass of 99.8% of all of the solar system. And we said that the solar system is a group of planets that orbit the sun. And we said that this orbit or the orbital or the orbitation of the planets is continuous in a specific orbit and it is not stable. No, the sun moves and the whole planet move around it. And also we spoke about how some asteroids and comets penetrate our planet Earth every day, and these asteroids and comets are the remnants of some later or some earlier planets and stars that have died millions of years ago. And most of the orbits and asteroids in our planet or in our solar system is between Mars and Saturn, and the area that is known as the asteroid belt. So some of them sometimes escape of the gravitation and penetrate our planet. Likely, most of them burn out during the penetration process. And we also have spoken about the light year, and that because some planets are so far from us that we cannot measure the distance using the kilometer or the mile, so we tend to use the light year. So we'll continue today speaking about the Earth's movement. The Earth's movement. How does the Earth move? Have you wondered any day about this? How does our planet move?
Space time.
Time? Yes.
No space time.
What about the orientation process? Why does it move? And
What, teacher?
why does our planet move?
It's moved so we can. Yeah, it's a very not moves, teacher. There's some words like, for example, it's like didn't move like for 1 year, and we still like for this year, all of the year we have only sun. Do not have moon. Cannot see the moon. Only the sun. Like that.
Well,
There's
so
example.
nice. So Muhammad says that our planet moves because of we need to have our 4 seasons. If our planet doesn't move, then we will not have the 4 seasons. On the other hand, we will only have the sun for the whole of the year, or we will have darkness for the rest of the year. Either one of them. So nice, Muhammad. What else? Do you know that our planet, when it moves, it moves in a slope direction? It is not stable. This is the axis of our planet Earth. Okay, so consider it like north, south, east, and west, and that is
It's
the
like a
axis.
little bit curved.
And it moves to the right by 12, so 11 degrees, and this is loop. This loop, guys, is what makes the 4 seasons. Okay, and this just shows us the magnificence of our Creator. That without this loop, our whole system is gonna be destroyed. So everything in our planet is measured by femtometer. So let's start reading first about the globe.
Can I read, teacher?
Yes.
Okay. A globe is a kind of 3D map that is the same shape as the Earth. It is a guide, the shape of squashed ball on its surface. The globe shows the position of the oceans and landforms. The Earth is not positioned upright. Its axis is an imaginary line that passes through its center between the North Pole and the South Pole. This axis is titled in space at an angle of 23.5 from the vertical or 66.5 from the horizontal.
All right. So simply, our globe. Our globe means the universe we are living in, containing millions of solar systems. It is not a pool. It's not like our planet Earth. No, it's a geoid. A geoid means it's like a squashed ball. Just imagine that you have a ball and you squashed it. Okay, on its surface. Our globe shows us the positions of the oceans and also the landforms. Our Earth, our planet, while it moves, it is not upright. It is not upright. Yet its axis, this axis, which is an imaginary line, there's no such an axis on our planet. It's an imaginary one, referring to the directions of north, south, east, and west. This axis, okay, which is an imaginary line that passes through the center of our planet Earth. Okay, this one is titled with an angle of 23.5 degrees vertical or 6.5 horizontal. And this axis is what helps our planet to move and to alternate the day and night and also the 4 seasons. Here we have the North Pole, the Arctic Circle, the Tropic Cancer, the Equator, the Tropic of Capricorn, Antarctic Circle, and the South Pole. All of these are some imaginary lines that we draw on planet Earth in order to differentiate among the different seasons. Okay, what about the rotation? Rotation. What is the meaning of rotation?
I know.
What?
It's like the movement of the earth.
The movement of the Earth. Nice, I see. Can you read it, please?
Rotation. The earth turns all the time on its axis. It moves from west to east. One complete turn is called a rotation. The earth's rotation causes day and night.
So, here is our planet, and it's at the axis with the slope of 23.5 degrees. And now the Earth moves from the west to the east, from this place to that place. Because of this rotation, so now it moves, and we have here the sun. So if we have the sun here, this will be day and this will be night. Because of this rotation, this part will come here and it will have the day here, and this part will come here and will cause it the night. Like this. Imagine that. This diagram, for example, okay, this diagram shows a model of illustration how the Earth rotates. So you have here a pole and you put spine in it, and you start moving it. And with the other hand, you hold the torch, resembling the sun. You start rotation with the stability of your hand. So this part here has the day, and the other one has the night. Once you start rotation, the other part will come to the light, and the other one will move to the shade. Now here in the activity, we are asked to compare the Earth's rotation with the rotation of other planets in our solar system. We can do that later. Actually, they all share the same rotation, except of course for the angle of the rotation. Muhammad Al Khayyat.
Yes, teacher.
Can you read this part, please? The unequal length of day and night.
The sun does not rise at the same time every day. This is because the lengths of day and night change at different times of year. Look at the diagram below. Notice that the sun's rays light up half the earth that is facing the sun. This half is in the daylight. The outlet side of the earth is experiencing night. The boundary between day and night is called the circle of illumination.
What does it mean? Can you illustrate that, Muhammad? Muhammad. Yeah, can you illustrate what you just have read?
So half of the day, half of the earth is at the day side, and half of the earth is at the night side. The one with the boundary between them is called the circle of illumination. So where the light stops and becomes the night, that's called the boundary of the circle of illumination. The unlit side of the earth is experiencing night. Yeah, so the other side that doesn't have the sun or the sun's rays is night because it's dark. The sun's rays light up half of the earth that is facing the sun. This is the half that is in daylight. Pretty obvious. You see sun, you are in sunlight, you're in day. The sun does not rise at the same time every day, yeah. Every time it changes. You can't like always yeah. This is because of the lengths of the day and night change at different times of the year. And yeah, there you go.
Okay, thank you very much. So simply, as Muhammad has just said, guys, now we have our planet is orbiting around itself and also orbits around the sun. The sun is the main source for heat and light on our planet Earth. Okay, because of our orientation or because of our rotation of our planet, so we have the day and the night. As you can see in front of you here, that's the axis, that's the slope of 22.5 degrees, and here are the rays. Each part of here will have the sun rays, and of course the amount of heat will change, right? Because here the rays are directed and in a short distance, so here this place will be much hotter than that place, for example, and both of them has day at the same one. And also, guys, the other part here will be very cold because there is no sun rays, so this part will be in the shade or night. Once the circle of illumination is completed, circle of illumination refers to when the whole part that is in shade comes to be in light, meaning that half orientation or a half rotation of the planet Earth. Once the night becomes day, that's a circle of illumination. All right. Any questions so far? Any question?
No.
All right. Have you ever wondered why the timing of praying change?
Because of this,
Yeah, because of this. Because the sun doesn't shine at the same time each day. So, for example, if the sun shone at 7:30 in the morning, for example, 7:30 in the morning. So we will start praying, for example, at 7:25. Okay, if the sun shines at 6 a.m., we will pray starting from 5:55. Okay, because the sun changes when it shines, so we also change our praying times, and this is the only reason for the changement of our praying times. Alright, this diagram illustrates the unequal length of day and night, because here we have some close distance to the sun, so the rays of the sun is short, and it gives us here in this place more heat, and this place will stay in the sun or in the sun's rays for longer amount or longer time than that place, because here it's very close to the night and the rays are so long in distance. So once a circle of illumination starts, this place will go directly into the other side, which is in the shade, but this place here will take longer time or much time before it comes to the night and night comes to the day. The diagram shows how many hours of day and night there are at different places on planet Earth. For example, look at the equator, for example. The equator here in the middle of or the center of our planet, that is the equator. For example, if we looked at the equator, half of the equator is lit up, the other half is in darkness. This means that places at the equator have 12 hours of the year because it's directly here in the middle. So here we have 12 hours of day and 12 hours of night. Look at the tropical Cancer, for example. Here, the tropical Cancer. Most of the tropical Cancer is in the daylight, so it will not be here 12 hours, it will be more than 14 hours of day, and only we will have 8 hours of night. Look here, for example, at the tropical Capricorn, for example. Half of it, or more than half of it, is in the night. So we will have only about 8 hours in day, and the rest will be in night. Here in the Antarctic Circle, for example, only one or half an hour in the day, and the rest is totally night. Okay, so the circle of illumination shows us how, because of the axis and the angle that the Earth orbits itself, it changes the timing in each place on our planet. Okay, so look at the tropical Cancer. About 2/3 of the line is in daylight. Only 1/3 is shaded, and people at this latitude experience long days and short nights. So this is the only reason. I need you to memorize this diagram because it shows us how the timing on places or different places on Earth work. Use the diagram to work out the length of day and night at these places, as we have just said. And the
Teacher, I have a
diagram,
question.
yes, Hasim,
Does the change of the seasons affect the day and night?
of course,
So when it's summer, the
longer.
day is longer and the night is shorter.
Yeah, that's a
And
fact.
the opposite in the
Yes, and vice versa in winter.
yes.
And mention this because of this slope, we have different seasons in different parts in on planet Earth. So,
I
for
know.
example,
Right now in Australia, they have summer.
yeah, right now here we are in Saudi Arabia. We are in the northern hemisphere in this place. So we have summer right now. We have winter, but the other people in the south hemisphere they have summer. So different seasons because of this. Here we are so close to the sun Okay, if we are in summer, for example, we will become so close to the sun, so that's summer. But other people here will suffer from winter or experience winter. Okay,
Okay.
any questions so far?
No.
Shall we take the structure of Earth, or that is be sufficient for you? Shall we continue, or that is gonna be enough?
Ready? Or what?
No, shall we take those 2 pages also, or we will be sufficient with those 2 pages? What do you
Let's
think?
take one more.
What?
One is better.
Okay. Did someone enter? Safe.
Yes. So something like
Let's check this.
Monster Math presents Addition Below 10. Okay, class. Smile and learn. This has been my journey through the solar system, people. It was incredible. Whoa! That's so cool.
Greetings, Earthling. I need you for a new adventure. I hope you're ready. This is a very important mission. A gigantic asteroid is heading towards your planet, and we have to save it. We have to study the rotation and revolution movements of planet Earth to find out whether it will impact Earth or pass at a distance. Would you help me?
Sure, of course I would.
Mission commences now.
Right away? It's been ages. I've missed you.
There's no time to lose. I need you to tell me everything you know about the rotation and revolution movements of planet Earth.
It's your lucky day, my friend. This week we learned all about it in class, and I scored a 10. Top marks. Just like the rest of the planets in the solar system, planet Earth moves in 2 ways, rotation and revolution. Can you see how the Earth is spinning around its axis?
Peter, I think the screen is frozen.
The Earth spins around an imaginary line, which passes.
I beg your pardon, Hussein.
I think the screen is frozen.
Okay, no problem. I'll stop sharing and share again. I have no worries about this.
Teacher, apparently it has been stuck since 10:07 because that's the time it says on your computer.
And why haven't you told me?
Because you were explaining the same exact thing.
No, I wasn't.
Passes through the poles. If you look closely, you'll notice that the axis is a little in revolution. Just like the rest of the planets in the solar system, planet Earth moves in 2 ways, rotation and revolution. Can you see how the Earth is spinning around its axis? This movement is called rotation. The Earth spins around an imaginary line, which passes through the poles. If you look closely, you'll notice that the axis is a little inclined, almost 24 degrees. It takes planet Earth 24 hours to complete one rotation on its axis, which is the equivalent of 1 day. Rotation explains day and night. As you can see, it's daytime in the part of the Earth that faces the sun, and nighttime on the dark side. Do you understand?
I do. Rotation means the Earth is spinning around itself.
Exactly right. Now I'll explain revolution. The movement of the Earth around the sun is called revolution. The Earth takes 1 whole year to go around the sun. Before, people used to think that the orbit of the Earth around the Sun was cyclical, but they weren't right. As you can see here, the orbit is elliptical. Thanks to revolution and the inclination of the rotation axis of the Earth, we have 4 seasons: spring, summer, autumn, and winter. The more the hemispheres incline towards the Sun, the more directly the sunlight reaches the Earth's surface. It's warmer, and that's why it's summertime. By contrast, the other hemisphere is less inclined, so sunlight is less direct. That's why it's colder, and it's wintertime. Here, we can see that it's summertime in the northern hemisphere and wintertime in the southern hemisphere. The opposite will occur in 6 months. Sunlight will reach the southern hemisphere in a more direct way, and it will be summer, while in the northern hemisphere, it will be winter. Owing to the fact that the revolution of the Earth around the Sun doesn't take exactly 365 days, but 365 days and 6 hours, there are leap years, which have one more day, 366 days. That's why every 4 years, February has one more day, day 29.
Wow, how impressive. So these calculations mean that planet Earth is doomed? The asteroid will impact Earth in 1 minute. No!
Wait, did you take into account that this is a leap year?
Oopsie! Hold on. The Earth is safe from the asteroid. It will pass close by without hitting it. Yay!
And it's all thanks to the leap year.
Okay, grade 8. Any questions so far about rotation and revolution of the Earth?
Noted.
No.
Okay, let's stop the recording first.